Good morning. I'm saying good morning because for me it's morning. I know some of you sign in at 3 in the morning, so maybe it's morning for you too. We're going to review a couple of topics today, guys, just from the beginning of the year. These are rational functions, so I'm going to remind you that there's a few things we can get from that. Namely, let's see if there's any asymptotes. If we want to know if there's a vertical asymptote, we're going to set the denominator equal to 0. So x minus 5 equals 0. That means that maybe at x equals 5 we have a vertical asymptote. We can tell if we factor it before we even put it in the calculator, and notice it will not be an asymptote because in this case x equals 5 is going to be a point of discontinuity, being that we have the common factor in the numerator. So in order to find out where that point of discontinuity would be, it's going to be at x plus 5 when x is 5. Therefore, point discontinuity will happen when x is 5 and y is 10. We can also tell that there will be a slant asymptote. The slant asymptote because this is 1 degree higher than that. So we have no horizontal asymptote, we have no vertical asymptote, but in this case we had just a slant asymptote. If I want to find out what my intercepts are going to be setting the numerator equal to 0, except at the place where there's a point. So when the numerator equals 0, I have x plus 5. Therefore, at x equals negative 5, I'm going to have an asymptote. So at negative 5 comma 0, I'm going to have an intercept. And then if I want to find out where my other intercept is, recall we just plug in 0, which would leave only this behind. So at 5, for the y value, 0, 5, we also have an intercept. Okay, next up. Where does this one have any asymptotes? At 3x over x, they match. Instead of being 1 degree higher, we have y equals 3 as a horizontal asymptote. We set our denominator equal to 0 again. So we have a vertical asymptote at x equals 7. Okay, so we also talked about increasing and decreasing functions. I have this one on the graph for now. I also have it on my graphing calculator. So when I have it on my graphing calculator, if you can see, I typed in y equals x to the negative x to the third plus 6x plus 1. If I'm trying to look at that on a graph, and I want to know where this function's increasing, I simply trace to the low point, second, trace, this side's a 3 for the minimum value, and I'm going to left bound it, so left bound it a little bit, hit enter, right bound that a little bit, hit enter, and that low point is at negative 1.4 comma negative 4.66. That's what I have indicated over there on my graph. Do the same thing for tracing to the relative max, and that's where I got that from. So where is this function increasing? This function happens to be increasing at negative 1.4 until positive 1.4. We notice that increasing is always going to be x values. If I want to know decreasing, it would be from 1.4 to infinity, or from negative infinity until negative 1.4. And that's it. Good luck on the first part of the review.